right, here we go. It's the review time. Make sure you have these correct so you're ready for that quiz tomorrow. We are going to be using both our Trig library and our ARC Trig table. Now, the worksheet that you get to go out with the quiz may have that ARC Trig table on the back of the Trig library. If it does not, make sure that you have both available to you to use. All right, so a lot of these are simply going to be looking it up on the table to start with until we get down into a little bit further on or using a calculator. I did not put the Trig library on here just to save some space. So first one, arc sine of square root of 2 over 2. Remember, that's the ARC Trig library, so the short one on the half page. So this first answer is just pi over 4. That's just looking it up. Second one, make sure you're in arc cosine or inverse cosine chart. That answer is just pi over 6. Another work to do. And last one, arc tangent. Make sure you're in the correct column. You're looking at positive 1, and you get pi over 4. All right, next set. Make sure that your mode of your calculator is in radians. For those who did graphing calculator, the mode key, make sure it's been moved so it says radians. On the little red calculators, you're going to press the key that says D, R, G. And on that key, you want to move over to radians and press enter. So move over to radians and press enter. If you notice at the bottom of your screen, it should say RAD on the screen itself. Make sure that's true. So the first one, again, you're just typing it in the calculator. You've got some decimals in there, so watch out for those. You're going to 2 decimal places to make sure you're rounding correctly. So 0.64, 1.98, and 1.20. There's really no work to do for those problems. All right, starting with number 7, you have to do a little bit of work on these, and then you're just going to look them up in the table. This is the linear section, so A3 number 1. You want to, or not even A3-1, say A2. Isolate the inverse cosine. So because it's an inverse, that means that's what you're going to look up on your table. So this is A2, section A2. Look up inverse cosine of pi over 2. The answer should be 0. Next one, you're just going to divide both sides by 3. So we have inverse sine of x equals pi over 3. So again, you're going to look that up on your table, and we get square root of 3 over 2. All right, problem number 9, dividing both sides by 4. We have inverse cosine, so we're going to look it up in our trig table, our arc trig table, a little half sheet, and we get square root of 2 over 2. All right, problem number 10. Notice I've got this negative out front, so I have to get rid of that negative. So we're going to leave that 4x in the parentheses. We're just multiplying both sides by a negative 1 in order to eliminate the negative on the left-hand side. That 4 that's inside of the parentheses, you cannot touch it until you have solved for what is the inverse sine of negative pi over 4. So if you look up negative pi over 4 on your chart, so I think when we did this earlier, we actually wrote this in a different manner. We did 4x equals the sine of negative pi over 4. Again, just look it up in your arc trig table, and the inverse sine of pi over 4 is equal to negative square root of 2 over 2. At that point, that's where we want to get rid of the 4. I can't get rid of the 4 up until this point, so I need to divide by 4. Remember that dividing by 4 is the same thing as multiplying by 1/4. And so my left-hand side will just be x. On the right-hand side, I'm going to have negative square root of 2 on the top. And then on the bottom, we have 2 times 4, which is equal to 8. All right, problem number 11. Notice I have cosine or inverse cosine in 2 different places. Neither one of those are square, so I just want to combine them together as one statement. So the first thing I'm going to do is I'm actually going to move this pi, and I'm going to move the pi to the right-hand side. This can be done in a couple different orders. but for some people this might make a little bit more sense so I don't have a 0. Then I can get rid of my 2 cosine, so I'm going to subtract that from both sides. So on the left-hand side, I now have 4 minus 2, which is 2 inverse cosine of x. And on the right-hand side, I simply have pi. Dividing by 2, I have inverse cosine of x equals pi over 2. That gets looked up on the chart, and our answer is 0. All right, moving to the next section. In this section, you are going to go back and forth between the ARC trig table and the trig library. Remember, these are the ones that you're trying to find. If you were given one, what was the other? Some of them, you could do all of them by using Pythagorean theorem, but it's really not until you get to 18, 19, and 20 that you have to use Pythagorean theorem in order to solve. The first 6 are just using the charts. So make sure you pay attention to what's on the inside, whether it's inverse sine or just regular sine. So the first one, I have inverse sine of 1 over 2. So if I look that up on my ARC trig table, that's going to happen at pi over 6. So what is cosine of pi over 6? Going over to your trig library, that's going to give us square root of 3 over 2. So this is a process of going back and forth between the 2 tables. All right, next one. Again, always working from the inside out. We're starting with the inverse cosine of negative 1/2 on the arc cosine chart. So that's going to give me 2 pi over 3. And then going to my trig library, what is tangent of 2 pi over 3? It's negative square root of 3. Done. For number 14, we're going to be looking up the inverse cosine of negative radical 2 over 2. That does give me 3 pi over 4. On the trig library, that's going to give me square root of 2 over 2, or my answer. Problem 15. Again, starting from the inside out, still using that ARC trig table. Inverse cosine of square root of 3 over 2 does give me pi over 6. And then that answer on the trig library is equal to 2. All right, cotangent, inverse sine of negative 1. That's a negative pi over 2. Again, looking it up on the trig library, that's going to give me 0. Number 17, looking up inverse cosine of 1, that's going to give me 0. Well, the tangent of 0 is also 0. Make sure you go through both steps. That's been a problem for students in the past, not going through both steps. All right, problem number 18. For this set, remember you're looking for one of 3 triangles. You can only be in first, second, or fourth quadrant. If you have any of them that are positive for sine, cosine, or tangent, so if you have a positive value for sine, a positive value for tangent, that's going to be in the first quadrant. If you have a negative value for either of those, that's going to be in the fourth quadrant. Tangent. If you have cosine, cosine being positive is also in the first quadrant, but cosine being negative is in the second quadrant. Negative number, negative x. So make sure you pay attention to which quadrant you should be in, because that's going to tell you the signs of your values. All right, first one, everything's positive, good to go. That means we are in the first quadrant. This type, you are going to have to use Pythagorean theorem. Knowing that tangent is opposite over adjacent. So if I have just a 2, it becomes 2 over 1. So my opposite is 2 and my adjacent is 1, and those are both positive. Using Pythagorean theorem, I have 1 squared plus 2 squared equals my c squared. So 5 is equal to c squared, and c is equal to square root of 5. So on my diagram, I have square root of 5 for my hypotenuse. Now, so I found my theta, I found my angle there that I want to know, okay, so what's the sine of that angle? So sine of that angle is opposite over hypotenuse. So my opposite is 2. My hypotenuse now is square root of 5, because that's what I had to find. That needs to be rationalized as 2 square root of 5 over 5. Alright. I should leave myself some more space in there. Alright, next problem for number 19. I got a pen in my hand. For number 19, we want to do the cosine. Again, it's positive. I believe on your quiz, these will all be positive as well. So first quadrant. When I draw my diagram, cosine is adjacent over hypotenuse. So that means I need to find my opposite. Remember, theta is always at the origin. So using the Pythagorean theorem, I have 2 squared plus b squared equals 3 squared. And finish solving. So b squared is equal to 5, and b is equal to the square root of 5. That goes on my diagram. I actually want to know what's tangent of the same angle. So my tangent of the same angle is opposite over adjacent, so square root of 5 over 2. And it doesn't need to be rationalized. It's good to go. So that's my answer. This problem. All right, number 20. This time we're starting with sine. Sine is opposite over hypotenuse. First thing I realize when I see those numbers, I think Pythagorean triple. Anytime you have 5 as a hypotenuse, 3 as a leg, the other leg is automatically going to be 4. Not sure of that? Pythagorean theorem. Again, so we have a squared plus 3 squared equals 5 squared. Solving that, we have a squared equals 16. A is equal to 4. There we go. So I know my missing side was 4. I want to know what's cosine of that same angle. So my cosine of theta is going to be adjacent over hypotenuse. So my adjacent is 4, my hypotenuse is 5, and that one is done. All right. So let's move on down to the last section. These are the ones that you're going to solve. Get that trig function isolated first, and then you're going to have to look it up on the table. You can have multiple answers for each one. Alright, so isolate. So I'm going to subtract the 3 from both sides. So I have 2 cosine theta equals negative 1. Divide by 2, I have negative 1/2. So on your trig library, you want to look up every place where cosine is equal to a negative 1/2 to find your values of theta. It will occur in 2 different places, at 2 pi over 3 and at 4 pi over 3. That one's done. Number 22, I want to start by getting rid of that 4. So I have 5 radical 2 sine theta equals negative 5. Well, we don't have any that have a 5 in it, so that's something that's going to happen to that 5. So I'm going to divide by 5 radical 2 on both sides. It is dividing the whole thing. Left-hand side leaves me with sine theta. The right-hand side, those 5s are going to actually cancel, leaves me with a 1 on the top. So I have negative 1 over radical 2. That does need to be rationalized to give me negative radical 2 over 2. So my values of theta are going to be, looking it up on the chart, 5 pi over 4 and 7 pi over 4. Alright, problem number 23. Notice we have a squared in there, but because we only have sine in one place, we're going to solve by taking square roots. Still, we need to divide by 4. So I have sine squared theta equals 1/4. When I take the square root of both sides, I have to remember I'm taking the square root of top and bottom, and I also don't want to forget the plus minus sign. So the square root of 1 is 1, the square root of 4 is 2. Because I have both positive and negative 1/2, that means I want 4 answers. So I want any place that sine is equal to 1/2, or sine is equal to negative 1/2. And that's going to occur at pi over 6.